Hello, everybody. Welcome to a small podcast on machine learning. I'm Alvin, and this is Aditya. And today we'll be discussing about a very specific topic in machine learning, which is overfitting and underfitting. So, hi Aditya. Uh, what is overfitting?
So overfitting is when you have trained the model too much, you have done too many iterations, too many epochs. This can happen when you have a large data set or even a small data set. So overfitting means you have low bias and high variance. Low bias means the model is trained on too much, it's looking at too many of the small details. High variance means it is way too sensitive to the data in the data set. So that is what overfitting is.
Okay. So, now that you told what overfitting is, what is underfitting?
So underfitting is the exact opposite. That is high bias and low variance. So this is basically like you have trained the model too less. So it is not looked at the details much. It is prone to bias. So when you pose a question to it which is unique and it has not looked at yet, it will give a false value to give the wrong answer. So that is what underfitting is.
So, what are the causes of overfitting?
So overfitting can be caused by many things. One of the things are like complex. Your model is too complex. So too complex model means you have trained it for too long. That causes a huge number of parameters. You have way too many parameters in a model that causes overfitting. Or then there are other reasons for it, like your data set is too small or too large. If your data set is too small, that meaning is you have trained it for too many iterations, and that causes overfitting. If your data set is too large, that also causes overfitting because there will be a noise in the data, too much noise. The larger the data set, the more noise there will be, that causes overfitting. So that is what causes overfitting.
So now that you've told what causes overfitting, what do you think causes underfitting?
So underfitting is the exact opposite of overfitting. That is caused by your model is too simple. So if your model is too simple, that meaning it has very less parameters. So if it has less parameters, that meaning is you have not trained it for long enough time, or your data set is too small. So there are reasons like that. So when your data set is too small, or if you have not trained it for long enough, that basically means you have not captured the important features of your data set into the model. So if your model has not captured important features of the data set, it will underperform both in the training data set and your testing data set. That meaning is you get very low accuracy in both. But in overfitting, you'll get high accuracy in training data set and low accuracy in testing data set. So that is what underfitting is.
Yeah, so far we've learned how both overfitting and underfitting is bad. So how do we reduce it?
So it's not about reducing. We have to balance them, and I'll tell you why. We need to balance them because it's not possible to eliminate both. It's impossible to eliminate both. So when you have low bias, that causes high variance. When you have low bias, that basically means you're free from the details. You have learned all the small details, but that means we naturally have high variance, and the vice versa is also true. If you have low variance, you naturally have high bias because you're not sensitive to the data that causes bias. So it's about having a bias variance trade-off. You need to balance both the bias and variance. There are techniques for balancing them, and you need to employ those techniques and have a good bias variance trade-off based on your model.
So in decision trees, how do you balance overfitting and underfitting?
So when it comes to decision trees, like there are multiple ways you can balance overfitting and underfitting. So what you can do is you can let the decision tree fully develop. That basically means you're letting it completely overfit the model. You'll basically get 100% accuracy on your training data set, but then your testing data set accuracy will be very low. You let that happen, and then what you do is you prune off few branches on the tree. So like you remove few branches, so that is called pruning. And when you do that, you can basically do that until you get required accuracy on both the training and testing data set. So that is one way. Or you can also do that when it comes to like when you use software like Collab or Jupyter, you get to see the accuracy increase or decrease while training the model, while developing the uh, tree. So what you can do is you can just stop at the required accuracy, whatever accuracy. Let's say you hope for at least 95% accuracy. So it reaches that accuracy, you can just stop training the we can stop developing the decision tree and stop it right there, and that's your developed decision tree. So that is one way. Or you can also do it in other software, but then typically pruning is the recommended way of balancing overfitting and unfitting in decision trees.
So thank you, Aditya. We've learned a lot about overfitting, underfitting, and the causes of them, and also how to reduce and balance them. So machine learning is not just about accuracy, but also balancing bias and variance.
Yes, exactly. A good machine learning model has balanced both overfitting and unfitting using bias variance trade.
Thank you, everybody, for watching the video.